All right. Another case of a structure that you have to adjust is 5.2. So over octet. Sometimes you're going to see some atoms that have too many electrons and it can't hold it. Right. So in this case, just opposite, we will break the bond. When those atoms who is under octet, so we form bond, the one that's over octet will break the bond, and the bond have to go somewhere, right? Just destroy it. So we break that bond, and the bond becomes a lone pair. So one bond is 2 electrons, so that's a lone pair. All right, give you some examples. So ozone, O3. Right, so oxygen they are all oxygen. One of them going to be in the middle, right? And the rest going to be on the side. Okay. Now a little bit structure. Ta-da! All of them have 2 unpaired, 2 lone pairs. Now make a non-central octet first. So each non-central oxygen, each non-central oxygen atoms need 2 more bonds. So 1, 2, 1, 2. Okay, so you should get that structure. Now check real quick if everyone is octet. So start with the oxygen on the left side. 1, 2, 3, 4, 5, 6, 7, 8. So it's good. Try the oxygen on the right side. 1, 2, 3, 4, 5, 6, 7, 8. So that's all good as well. Now in the middle though, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Blech. They said over octet, right? Oxygen has only 1 s orbital and 3 p orbital, so 8 electrons total. Cannot hold 10 electrons. So here's what we're gonna do. So for the over octet, we break bonds, and the bond becomes the lone pair. You can break on either side, right? If you do on the left side, you should get that structure. On the right side, you should get the other structures. Right, and if you look at right here, it looks like that the lone pair, start with the blue lone pair, can delocalize or can move along the bond. Look at something like this. Go to the right, and the right can go to the left, kind of. Right. So ozone got 2 structures. We call these 2 structures the resonance structures. We'll talk about the resonance in a bit. Okay. All right. Now let's try the NO2. Right. Nitrogen gonna be in the middle. Right, so 3 bonding capacity versus 2 bonding capacity of oxygen. Next one, a little bit simple. So nitrogen, 3 unpaired, right? 3 unpaired electrons. Oxygen, 2 unpaired electrons each. Now make oxygen octet first, so 2 bond. There we go. All right. So what we have left? We have just nitrogen in the middle, just an unpaired. Well, that's what you get. You can't do anything else with it. But if you count the number of electrons, so both oxygen are octet. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So both oxygens are octet. Nitrogen though, 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. Nitrogen cannot hold 9 electrons, so you have to break bond. On either side, pick one. On the left side, you get that. On the right side, you get that. Okay, and it looks like this electron the blue electron can flow along the bond. Yeah, there's another NO2 got 2 resonance structure as well. Okay, some of you ask, hey, hold on, this nitrogen is not octet. 1, 2, 3, 4, 5, 6, 7, only 7 electrons. Well, that's all it got. You can't do anything with this. So sometimes, well, that's the reason why NO2 is not that stable. Okay, usually do reaction later. Usually meet up with the oxygen in the air and then undergo oxidation reaction, become nitric acid. Okay. All right, let's practice on your own right here.